As promised in the first video, and this video will get the motors up and running. We'll start by unplugging our USB cable. One nice thing about the system we're using is we don't need it plugged into our laptop to run it. We can actually leave that plugged in, but for demo purposes, I'm just going to go ahead and disconnect the wire. For plugging in the battery, it's important to get the polarity correct. So we'll look for the plus sign on the battery and make sure that's on the red wire side for the battery connector itself. Your battery should snap in nicely. I do like having it also the extra security of velcroing it down. It also acts as a way to keep these wires from getting too out of control. One extra important thing when you're going to turn on the switch that actually powers the motors is that you want the wheels off the ground. You don't want there to be a chance that your device is going to run away from you, run off the table and damage any of the microcontroller components that you have. So I'll pretty much always put it up on a box like this to make sure that it never just runs away on me. Now before I do anything with the motors, I'm going to make sure that that LED sketch still works now that I have this thing connected just to the battery. And there are two switches. I've got one switch here which controls power from the battery to the expansion board, and another switch here that controls power from the battery to the motor driver, and therefore the motors. So if you don't see the voltage tester reading anything, it means this switch is not powering the motors itself. So I'll start by just turning on the microcontroller, and you should see a few lights turn on. Sometimes you'll see some lights here on the microcontroller itself, and at the very least you'll see the lights here down on the encoders. And that's because the encoders, not the motors, but the motor encoders, are powered by the microcontroller's power source. Let's see if that LED sketch still works. One nice thing about using JAG is that, one nice thing about the Claremont ETC network is that typically you'll get the same IP address when you restart your device. So even though I'm not currently connected to the microcontroller with USB, I can be pretty sure that it has the same IP address. If there were other devices here in the room with me, I would double check by plugging in the USB connector, or by making sure that my microcontroller was displaying its IP address on the display. And that's something we'll make sure that you all do for next week. This week, though, it's okay to always have your USB connected in. It looks like it still found my device. It's programming the device. And there, it has our LED blinking. So that sketch still works. Now let's look into the motor sketches. But before I actually run the program itself with JAG run demo, we're going to look at the program. But I also want to take note here, the fact that I don't have this voltage tester, again, displaying any values means that the battery is not connected to the motors themselves. Something else to keep aware of is I want you to continually monitor those things. So anytime you think about it, you should be glancing at the voltage being read on this screen here, because we never want the voltage on of your batteries to go below about 3.5 volts. We'll reduce the lifespan of your battery if you let it go about below that number. Alright, but let's first start by looking at the demo program. The JAG code is fairly similar to Python, so it shouldn't be too odd to look at. But here I've got 3 seconds defined, 1 second defined, time between updates. The rest of this code is fairly self-explanatory, so I'll just highlight a few interesting parts of it. I print out running forward. We won't actually see that because I don't have this thing connected to my laptop over USB. I'm going to set the motors forward to half speed, run that for 3 seconds, stop for 1 second, then run the motors in reverse half speed. That's what the negative sign here is doing. Reverse half speed for 3 seconds, and then again stop for 1 second. And then we'll just continually do that. So while true, we'll continue to cycle the motors forward, stop, then reverse, and stop again. The program is now running. You notice the LED light is no longer flashing. But to have the motors actually turn, I need to turn power onto them. Alright, that looks like forward. That's reverse. And due to flashing, you may not be able to see the battery voltage very well, but it's currently reading at about 4.1 volts. Jumps between about 4.1 and 4.2. If that were to ever get down to about 3.5, I'd want to make sure to turn this off and swap out the battery.